Hello everyone and welcome back to the next lecture of control systems. In this presentation we are going to have the review of Laplace transform part 3. And in this presentation we are going to continue our discussion on the properties of Laplace transform. So let's get started. In the previous lecture we have already discussed two properties of Laplace transform. One was the linearity property and the other was the time scaling property. Now in this lecture we are going to have our third property, which is the time shifting property. So if f of t is a time domain function which is having a Laplace transform f of s, then in f of t we are going to have the time shifting in two different ways. One is the right shifting and the other is the left shifting. So if I perform the right shifting to this function, then we can write f of t minus t naught, and its Laplace transform is given as f of s multiplied e to the power minus st naught. This negative sign here is the same sign that we are having due to right shifting, and the t naught is the factor by which we perform the right shift. Similarly, if I perform the left shifting, then we can write this function as f of t plus t naught, and its Laplace transform is given as f of s multiplied e to the power s t naught. This positive sign is the same sign that we are having here due to the left shift, and t naught is the factor by which we perform the left shifting. So by time scaling property, we can say that the shifting in time domain is the exponential multiplication in the frequency domain with the same sign. If we perform the right shifting, then this negative sign will be same in this particular exponential function. And if we perform the left hand shift, then this positive sign will be same in this exponential function. So now we are done with the property, and now we will take one example to understand this in a better manner. And the example is given as, find the Laplace transform of u of t minus 2. Now here we can see that u of t minus 2 is the time shifted version of u of t. And can you answer which type of shift is this, the left hand shift or the right hand shift? Yes, it is the right hand shifting, and this is our first case, f of t minus t naught, and its Laplace transform will be f of s multiplied e to the power minus st naught. And in this case, f of s will be the Laplace transform of ut, and we already know the Laplace transform of ut, right? It is 1 over s. So moving on to the solution, we will have the Laplace transform of ut is equal to 1 over s. And now we will perform the shift to the time domain, and we will have the exponential multiplication in the frequency domain by the time shifting property, and we will have Laplace of u of t minus 2 is equal to 1 over s multiplied e to the power minus 2s. So if we are shifting this function to the right side in the time domain by a factor of 2, then in the frequency domain we will have the exponential multiplication with the same sign by a factor of 2. So now we are done with the time shifting property, and we will now move on to the next property, which is the frequency shifting property. And as the name suggests, we will now perform the shifting in the frequency domain. And that's why this property is also known as shifting in S domain. So if f of t is a time domain function which is having a Laplace transform f of s, then e to the power s naught t f of t will have a Laplace transform f of s minus s naught. In this case, we are performing right shifting in the frequency domain, and that's why we get an exponential multiplication in the time domain. We can see that if we are having a negative sign here, we are having a positive sign in the exponential function, and s naught is the factor by which we are performing the right shift. Similarly, if we perform the left shifting to the frequency domain, we will have e to the power minus s naught t f of t will have a Laplace transform f of s plus s naught. In this case, we are performing the left shifting in the frequency domain, and that's why we are getting an exponential function with the negative sign in the time domain. So we can say that shifting in frequency domain will result to the exponential multiplication in the time domain with an opposite sign. We can remember this property like this. If e to the power s naught t is the factor which is multiplied in the time domain of the function, then we need to replace s by s minus s naught. Similarly, if e to the power minus s naught t is the factor which is multiplied in the time domain, then we need to replace s by s plus s naught. So let's understand this property with the help of an example, and the example is given as: find the Laplace transform of the function e to the power minus at cos omega t. Now in this case, we know the Laplace transform of cos omega t, right? What is the Laplace transform of cos omega t? Yes, it is s over s square plus omega square. But in this case, we are having an exponential function e to the power minus at multiplied with this function. So we can easily find out the Laplace transform of this function by using the frequency shifting property. Moving on to the solution, we are having the Laplace transform of cos omega t as equal to s over s square plus omega square. And now we are having e to the power minus at multiplied with cos omega t. So we need to replace s by s plus a. Because if we are having e to the power minus s naught t multiplied with f of t, we need to replace s with s plus s naught. And in this case, s naught is equal to a. So we need to replace s with s plus a. So we will have Laplace transform of e to the power minus at cos omega t is equal to s plus a over s plus a whole square plus omega square. So now we are done with the frequency shifting property. Till now we have discussed 4 properties. We have 2 more properties left in the review of Laplace transform. One is the differentiation property and the last one is the convolution property. These are the homework questions which are based on the properties of Laplace transform that we have discussed till now. Pause this video and try these questions on your own.